Okay, so right side, pick a number that's greater than -2. What's a really easy number that's greater than -2? 1, 0 really is the easiest number that's greater than -2 to plug in, because 0 times anything is 0, so that would give us -1, 0, -1, so I can draw the right side. So it kind of sort of looks like an absolute value. Kind of sort of looks like an absolute value function, right? But the two sides have different slopes. Okay, the left side has slope of +1, the right side has a slope of -2. So anyway, look at that graph. Are there any breaks or gaps in that graph? No. If I start on the left side of this graph, I can trace my finger and I can trace the entire graph without picking my finger up. That's another way of looking at continuity. So this one is continuous. Okay, this one is continuous because there are no breaks, there are no gaps. What's the key? Where would or could the issue be with this? Where would the break or the gap occur if there were one? Where would it happen? Where it changes from one function to another. So at this point, at the point of your inequality, in this case -2, that's where the question is. Is there a break? Is there a difference in the y value for the two pieces? Okay, so if you're trying to decide if something's continuous, you need to see, well, if I plug it into this piece and I plug it into that piece, do I get the same value? Let's look at another one really quickly to practice graphing as well as talking about this idea of continuity. Okay, -x + 4 when x is less than or equal to 0, 2/3 x minus 1 when x is between 0 and 5, and just plain 2 when x is greater than 5. So, start with that first piece. 0, plug in 0. 0 doesn't have a negative, so it's still just 0 + 4. So 0, 4, this is equal to, so we put a point, plug in -1. Okay, -1 is +1, + 4 is 5. You can, of course, use your calculator. I just like practicing. So that's what that piece, the first piece, looks like. Stops at x = 0. All right, second piece. Plug in 0. 2/3 times 0 is 0, minus 1, -1. It has an open circle because it's not equal to 0. That's where the point would be, but it's not. So already we can tell this one is not continuous. So we've already answered the question. It's not continuous. But for the sake of practicing, let's continue. Okay, plug in 5. 2/3 times 5 is 10/3. Minus 1 would be 7/3, which is a little bit bigger than 2. So 5 is out here, a little bit more than 2. This one gets a point because it was equal to 5. Okay, it is equal to 5, so then I can connect those 2 points because those are the endpoints there for that middle function. And then the last one, when x is greater than 5, it's always equal to 2. So open circle at 2, and it's 2 for forever past that point. As long as x is bigger than 5, the y value is always equal to 2. So obviously this one is not continuous, but that's another review of graph.